Good morning, my dear students. Today, in this video clip, I want to discuss about that is a car move on a level road and a car move on a banked road. That is the concept of angle of banking. And in both the cases, we have to derive the expression for maximum speed of the moving car on level road and banked road without skidding. You obtain the expression for the maximum speed of the moving car on level road without skidding, and another expression also maximum speed of the moving car on banked road without skidding. ಈ ಥರ ನಾವು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಡಿರೈವ್ ಮಾಡ್ತೀವಿ. ಬಿಫೋರ್ ಗೋಯಿಂಗ್ ಟು ದ್ಯಾಟ್ ಪಾಯಿಂಟ್, I want to request to all my dear students to become a subscriber for our physics channel. How you become a subscriber? First, you have to press the subscriber red color button and bell button. Then you become a subscriber. Okay, I hope all of you become a subscriber. Then I want to discuss about this is the speed of the moving car on level road. Yes, already you know that is concept of that is the centripetal force, centrifugal reaction. Centripetal force is equal to centrifugal reaction, no doubt. It is not a force, centrifugal force, it is not a force, it is a reaction of the centripetal force. But it is said to be pseudo force. There is no reference point for the pseudo force. Therefore, that is the centrifugal force means centrifugal reaction. Therefore, it is said to be pseudo force. That expression mv square by r. What is m here? Mass of the particle or a body moving a circular path. What is r? Radius of the circular path. And what is v? Velocity of the particle or a body which is moving a circular path. Now, another point that is said to be friction. The force of static friction, which is the force exists between the two surfaces or contact one and another. Whatever the component of the force, it is along the parallel to the surface where they are contact one and another. That is said to be force of friction or said to be friction. If it is a particle is at rest or a body is at rest, now that friction is said to be static friction. Once the body moves on surface of the another body, whatever the friction, that friction is said to be kinetic friction. If it is rolled, that is said to be a rolling friction. Now, the maximum force of friction is said to be limiting friction. The maximum force of friction is said to be limiting friction. At that time, we have to take the expression that is the limiting friction that is equal to or less than mu s into n. N is said to be normal reaction, and then mu s is said to be coefficient of static friction. According to second law of friction, that is the force of static friction or a force of friction, any friction, force of static or kinetic or rolling, whatever it may be, the force of friction is directly proportional to what you say normal reaction. And remove that proportional, that is proportional, and then you write equal sign. You remove that proportional sign and then you write the equal sign. It becomes mu s. Mu indicate coefficient of friction. If it is mu s, coefficient of static friction. If it is mu k, coefficient of kinetic friction. If it is mu r, coefficient of linear friction. Then you come to the point. You know the idea about the centrifugal force, centrifugal reaction. You know the idea about the force of friction, the friction, and one more you got the normal reaction. Any body is placed on surface of the other body, and one of the force, component of the force is which is perpendicular to the surfaces where they have contact one in another. That is said to be normal reaction. ಅದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ normal reaction ಅಂತ ಹೇಳ್ತೀವಿ. It is perpendicular to the surfaces which have contact one and another. If it is not perpendicular, you have to take the component. Surface is perpendicular ಅಂದ್ರೆ ನಾವು ಅದನ್ನ ಏನು ಮಾಡ್ತೀವಿ ಕಾಂಪೊನೆಂಟ್ ಕೂಡ ಡ್ರಾ ಮಾಡ್ಕೊತೀವಿ. Now we come to the level. I want to give the example. ನೀವೇನು ಮಾಡ್ರಿ, ಒಂದು ವೆಹಿಕಲ್ ತೊಗೊಂಡು ಹೋಗ್ತಾ ಇದ್ದೀರಾ, ಒಂದು ವೆಹಿಕಲ್ ತೊಗೊಂಡು ಹೋಗ್ತಾ ಇದ್ದೀವಿ, ಆ ಸ್ಟ್ರೇಟ್ ರೋಡ್. You have to take the turn either in left side or right side. ನನ್ನ ಕಡೆಗೆ ಏನಾಗುತ್ತೆ, ಈ ಕಡೆ ಲೆಫ್ಟ್, ಈ ಕಡೆ ರೈಟ್ ಆಗುತ್ತೆ. ಲೆಫ್ಟ್ ಸೈಡ್ ಆರ್ ರೈಟ್ ಸೈಡ್ ಮಾಡಬೇಕಾಗಿದ್ದೇನು ಫಸ್ಟ್ ನೀವೇನು ಮಾಡ್ತೀರಿ, ಈ ಟರ್ನ್ ಮಾಡಬೇಕು. ಫಸ್ಟ್ ಏನು ಮಾಡ್ತೀವಿ, ಔಟ್ ಟು ಅಪ್ಲೈ ದ ಬ್ರೇಕ್. ಬ್ರೇಕ್ ಅಪ್ಲೈ ಮಾಡೋದು ಏನಾಗುತ್ತೆ, ದ ಸ್ಪೀಡ್ ಆಗುತ್ತೆ, ಡೌನ್ ಆಗುತ್ತೆ, ಸ್ಪೀಡ್ ಡೌನ್ ಆಗುತ್ತೆ, ಸ್ಪೀಡ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ದೆನ್ ಯು ಟೇಕ್ ದ ಟರ್ನ್, reduce the speed, then you take the turn. If suppose in the same speed of the vehicle, suppose you suddenly you take the turn, what happens? That vehicle becomes skid ಆಗುತ್ತೆ, ಸ್ಕಿಡ್ ಆಗಿ ಬೀಳುತ್ತೆ. ಈ ಕಡೆ ತೊಗೊಂಡು ಈ ಕಡೆ ಬೀಳುತ್ತೆ, ಈ ಕಡೆ ತೊಗೊಂಡು ಈ ಕಡೆ ಬೀಳುತ್ತೆ. ಬಟ್ ಸ್ಕಿಡ್ ಆಗದೇ ನಾವು ಟರ್ನ್ ಮಾಡಬೇಕಲ್ಲ, ಯು ಹ್ಯಾವ್ ಟು ರೆಡ್ಯೂಸ್ ದ ಸ್ಪೀಡ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು ಹೇಳ್ತೀನಿ, 2 meter per second. 2 meter per second vehicle move ಆದರೆ you have to easy to take the turn. If it is 3 meter per second, definitely skid that vehicle. If it is 2 meter per second, no, easily you have to take the turn. 2 meter per second it is said to be maximum speed of the car which you take the turn without skidding. That expression I am going to derive that expression in this class. Okay. And if it is moved 1 meter per second, no problem. Skid agolla. 2 meter per second, skid agolla. That is the ultimate maximum. If it is 3 meter per second, skid that vehicle. ಏನಾದರೂ ತೊಂದರೆ ಆಗುತ್ತೆ. If it is 4 meter per second, at that time also skid that vehicle. ಇನ್ನೂ ತೊಂದರೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. 5 meter per second, ಇನ್ನೂ ಜಾಸ್ತಿ ತೊಂದರೆ ಆಗುತ್ತೆ. Like that. 2 meter per second is the ultimate maximum speed which you have to take the turn in take the turn on a level road by using that car, that vehicle. You have to take the turn. That is the 2 meter per second. It is an example only, depending upon whatever the mass of the vehicle, but what direction you have to take, in what circular path, what is the radius, depending upon all these things you have to see. Yes, you come to that point, you have to derive the expression. Now, a car moves on a level road and equation of a maximum speed without speed. Equation of maximum speed without speed. Now see here, this is said to be level road. This is the level road. ಹೀಗೆ level road ಅಂದರೆ ಹೀಗೆ ತಗೊಂಡು ಬರೋದು. level road ಹೀಗೆ ತಗೊಂಡು ಹೋಗೋದು. ವೆಹಿಕಲ್ ಹೀಗೆ ಹೋಗ್ತದೆ, ಹೀಗೆ ಟರ್ನ್, ಹೀಗೆ ಟರ್ನ್. ಇದು ಲೆವೆಲ್ ರೋಡ್, ಹೀಗೆ ಟರ್ನ್ ತಗೊಂಡು. ಓಕೆ, ಲೆವೆಲ್ ರೋಡ್ ಆ್ಯಂಡ್ it is a vehicle move like this. It is moving in a circular path of radius r. What is m? M is the mass of the car. What is FCP? FCP is the centrifugal force which is acting on moving car in the circular path with the speed v. What is Fs? Force of static friction. Suppose you have to take in this direction also, it is equal and opposite, no problem. ನೀವು ಇಲ್ಲಿ ತಗೊಂಡ್ರು ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಇದರಲ್ಲಿ ಬುಕ್ ಮಾಡೋದಿಲ್ಲ, ಹೀಗೆ ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ. FSC ತಗೊಂಡು ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್, ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಹೀಗೆ ಮೂವ್ ಆಯಿತು, ಸೆಂಟ್ರಿಫಿಕಲ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಯಿತು. ಹಾಗಾದರೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗಿರ್ತದೆ? ನಾವು ಎಮ್ ಈಸ್ ಮಾಸ್ ಆಫ್ ದಿ ಕಾರ್, ಎಫ್ ಸಿ ಬಿ ಈಸ್ ಸೆಂಟ್ರಿಫಿಕಲ್ ಫೋರ್ಸ್, and b is velocity of the moving car, and r is radius of the circular path. R is the radius of the circular path. What are the forces are acting? Now see here, one is weight. This is the gravitational force. It is act on a car in a vertical direction, vertically downwards, m into z. M into g. This is mass into acceleration due to gravity. Mass into acceleration due to gravity. Another one is normal reaction. Normal reaction. And force of friction. Another one is force of friction. The maximum force of friction, static friction, limiting friction. That is F is less than or is equal to mu s. And another force is centrifugal force. There is no reference. If it is moving in a circular path, there is a centrifugal force. Now you observe this one. In a vertical direction, what is the net force? Net force in a vertical direction. Net force, ಇದು ಕೆಳಗೆ ಬರಲ್ಲ, ಮೇಲೇನೂ ಹೋಗಲ್ಲ. ಅದರ net force equal to 0. Net force means one is N, another one is W, mg, N minus mg equal to 0. Now what is N here? N is equal to M. This is equation. This is in vertical direction. You got N is equal to mg using this concept. This concept. This is N is equal to mg. ಅಂದರೆ ಎಷ್ಟು ಇರುತ್ತಾ ಇದು ಅಷ್ಟೇ ಇರುತ್ತೆ. ಇನ್ನು ಹಾರಿಜಾಂಟಲ್, what about horizontal? In horizontal, centripetal force is equal to friction, static friction. ಈಗ ಹೀಗೆ ಟರ್ನ್ ಇರುತ್ತಪ್ಪ, ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಐತೆ ಅಂತ ಹೀಗೆ ಹೋಗೋದಲ್ಲ, ಹೀಗೆ ಹೋಗ್ತಿರ್ತದೆ. ವೈ? ಬಿಕಾಸ್ ಇಟ್ ಬ್ಯಾಲೆನ್ಸ್ಡ್ by the force of friction. Therefore, centripetal force is equal to force of static friction, mv square by r. What is centripetal force here? mv square by r is equal to, what is Fs? This is Fs mu s into n. ಅವಾಗ ಇದು ಮ್ಯಾಕ್ಸಿಮಮ್ m ಏನು ಬರೀಬೇಕಾಗುತ್ತೆ? ಇಲ್ಲಿ ಇಸ್ ಈಕ್ವಲ್ ಟು n ಬರೀರಿ. ಇಲ್ಲಿ ಏನು ಬರೀಬೇಕಂತ ಹೇಳಿದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಂದ್ರೆ ಹೀಗೆ ಬರೀಬೇಕು. ಆ್ಯಕ್ಚುಲಿ ಹೀಗೆ ಬರೀಬೇಕು. ಎಸ್ ಎಮ್ ಬಿ ಸ್ಕ್ವೇರ್ ಬೈ ಆರ್ mu s into m into c. m ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಯಾಕೆ? ನಾ ಏನು ಬರೆದೆ? ಎಫ್ ಸಿ ಬಿ ಎಮ್ ಬಿ ಸ್ಕ್ವೇರ್ ಬೈ ಆರ್ ಬರೆದೆ. ಇದನ್ನ mu s into n ಬರೆದೆ. ಬಟ್ instead of n you have to take the m into c. m into c ತಗೊಂಡು m ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಓಕೆ, m ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು. ಎಸ್, ಓಕೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ? b ಸ್ಕ್ವೇರ್. b ಸ್ಕ್ವೇರ್ ನಾನು ಏನು ಬರೆದು? ಮ್ಯಾಕ್ಸಿಮಮ್. What is the expression for this one? V maximum is equal to root of mu s into rg. So see here, this is the maximum speed of the moving car on a level road in a circular path without sliding. Now depending, it is under root of mu s rg. It mainly depending upon the two important points. One is coefficient of friction and radius of the circular path. Okay, now long term ತಗೊಂಡ್ರೆ velocity ಹೆಚ್ಚಿದ್ರೂ ಸ್ಕಿಡ್ ಆಗಬೇಕನ್ನೋ ತಗೋಬೋದು. ಸ್ಮಾಲ್ ಟರ್ಮ್ ತಗೋಬೇಕಂದ್ರೆ ಏಕದಮ್ ಡೌನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ velocity. ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ರೇಡಿಯಸ್ ಕಡಿಮೆ ಇತ್ತು, ನಿಮ್ಮ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಇರಲೇಬೇಕು. ಅದೇ ರೀತಿ ಫ್ರಿಕ್ಷನ್, ಮೋರ್ ಫ್ರಿಕ್ಷನ್ ನೋ ಪ್ರಾಬ್ಲಮ್, ಮ್ಯಾಕ್ಸಿಮಮ್ ಸ್ಪೀಡೇ ತೊಗೊಂಡು. ಫ್ರಿಕ್ಷನ್ ಎಲ್ಲ ಜಾರಿ ಬೀಳುತ್ತೆ, ಸ್ಕಿಡ್ ಆಗುತ್ತೆ. That is which expression shows mainly depending upon coefficient of friction and the radius of the whatever it is the circular path. This is about level one. And another one is bend. ಏನಂದ್ರೆ ಇನ್ನೂ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆಗಬೇಕು, ನಾ ಟರ್ನ್ ತೊಗೊಳಕಬೇಕು, ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಬಟ್ ರೇಡಿಯಸ್ ಕಡಿಮೆ ಐತಿ. ಏನು ಮಾಡಬೇಕು? ಯು ಹ್ಯಾವ್ ಟು ರೈಸ್ ದ ಔಟರ್ ಪೋರ್ಷನ್ ಆಫ್ ದಿ ರೋಡ್. ಈಗ ನಾನೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಇದು ರೋಡ್ ಅಪ್ಪ, ಇದು ನಮ್ಮ ವೆಹಿಕಲ್. ನಾನು ಏನು ಮಾಡ್ಬೇಕಾಗೈತಿ? ಹಿಂಗೆ ಹೋಗಿ ಹಿಂಗೆ ಟರ್ನ್ ತೊಗೋಬೇಕು. ವೆಹಿಕಲ್ ಹಿಂಗೆ ಮೂವ್ ಆಗ್ತದೆ, ಹಿಂಗೆ ಟರ್ನ್ ಏನು ಮಾಡಬೇಕು, ಇದು ನೀನು ರೈಟ್ ಸೈಡ್ ಟರ್ನ್ ಹಾಕಿಲ್ಲ, ಇದನ್ನು ರೈಸ್ ಮಾಡು. ಲೆಫ್ಟ್ ಸೈಡ್ ಟರ್ನ್ ಹಾಕಿದ್ರೆ ಇದನ್ನು ರೈಸ್ ಮಾಡು. ಔಟರ್ ಪೋರ್ಷನ್ ಆಫ್ ದ ರೋಡ್ ಇಸ್ ರೈಟ್ ವಿತ್ ಸರ್ಟನ್ ಹೈಟ್ with certain angle to the horizontal. This angle is called angle of banking. ಇದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ, angle of banking. To avoid the skidding of the vehicle and avoid the friction, more friction between tires and the surface of the road, then outer portion of the road is raised with certain height to the horizontal. This is called angle of banking. To avoid the skidding, the outer portion of the road is raised with a certain angle of banking, then that road is said to be banked road. ಅಂತ ರೋಡಿಗೆ ನಾವು ಹೇಳ್ತೀವಿ banked road ಅಂತ ಹೇಳ್ತೀವಿ. Don't think like a bank. ಬ್ಯಾಂಕ್ ನಾವು ಕ್ಯಾಶ್ ಕಟ್ತೀವಿ, ಕ್ಯಾಶ್ ತೊಗೊಳ್ತೀವಲ್ಲ ಬ್ಯಾಂಕ್, ಅದನ್ನ ನೆನೆಸ್ಕೊಳ್ಳೋ ಹಾಗಿಲ್ಲ ಇದೆ. ಬ್ಯಾಂಕ್ ಅಂದರೆ ಹೀಗಿರೋದ್ರೆ ಹೀಗೆ ಸ್ವಲ್ಪ ಔಟರ್ ಪೋರ್ಷನ್ ರೈಸ್ ಮಾಡೋದು. ನಾವು ರೈಟ್ ಸೈಡ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಏನು, ಲೆಫ್ಟ್ ಸೈಡ್ ಟರ್ನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಈ ಕಡೆ ಔಟರ್ ಪೋರ್ಷನ್. ನಾನು ರೈಟ್ ಸೈಡ್ ಟರ್ನ್ ಅಂದ್ರೆ ಲೆಫ್ಟ್ ಸೈಡ್ ಔಟರ್ ಪೋರ್ಷನ್ ಇರುತ್ತೆ. ನಾನು ಲೆಫ್ಟ್ ಸೈಡ್ ತೊಗೊಂಡ್ರೆ ರೈಟ್ ಸೈಡ್ ಔಟರ್ ಪೋರ್ಷನ್ ಇರುತ್ತೆ. ಔಟರ್ ಪೋರ್ಷನ್ ಆಫ್ ದ ರೋಡ್ ಇಸ್ ಲೈನ್ ವಿತ್ ಸರ್ಟನ್ ಆ್ಯಂಗಲ್ ಟು ದ ಹಾರಿಜಾಂಟಲ್. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆ್ಯಂಗಲ್ ಆಫ್ ಬ್ಯಾಂಕಿಂಗ್. ಈಗ ರೋಡ್ ನಮ್ದು ಹಿಂಗಿತ್ತು, ಹಿಂಗೆ ತೊಗೊಳ್ತೀವಿ. ಈ ರೋಡ್ ಏನು ಮಾಡಿದ್ರೆ ಹೀಗಿಲ್ಲ, ಇದು ಸ್ವಲ್ಪ ಹಿಂಗೆ ಬರುತ್ತೆ. ಅಂದ್ರೆ ವೆಹಿಕಲ್ ಹಿಂಗೆ ಬರ್ತಾ ಇದೆ, ಹೀಗೆ ಬರ್ತದೆ. ಈಗಲ್ಲ ತಪ್ಪದು ಹೀಗೆ ಹೀಗೆ ನಿಮ್ಮ ಮುಂದ್ಗಡೆ ಹಿಂಗೆ ಹೀಗೆ ಬರ್ತಾರೆ. ರೋಡ್ ಹಿಂಗಿದೆ, ರೋಡ್ ಹಿಂಗಿದೆ, ಹೀಗೆ ಹೋಗ್ತಾ ಇಲ್ಲ, ಹೀಗೆ ಬರ್ತಾ ಇದೆ, ಹೀಗೆ ಬರ್ತಾ ಇದೆ. Now this is theta is angle of banking. Theta is angle of banking. M is same thing. M is mass of the car. P is the velocity of the car. Whatever the thing you have to explain in this point, same point you have to take here. M is the mass of the car and P is the velocity of the moving car. Now centripetal force act on this one. Due to the mass, the gravitational force act on that car, and there is the friction between the tires and the surface of the wheel. Everything you have to take same explanation. Whatever the points are there here in this case, same explanation. Now see here. Now this is weight. W, weight of the body, M into Z. This is normal reaction. But the road is like this. Road higide. Road higide. Road higirudda. ನಮಗೆ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಹೇಗಿರುತ್ತೆ ಅಂದ್ರೆ ಹೀಗೆ. ಈ ಸರ್ಫೇಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್, ಇದು ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್. ಹೀಗಿರೋದು ಕಾಂಪೊನೆಂಟ್. ನೀನು ಈ ಕ್ವಶನಿಂಗ್ ರೈಸ್ ಮಾಡಿ ಅಂದಮೇಲೆ ಇದು ಥೀಟಾ ಇದೆ ಅಂದಮೇಲೆ, ಇದು ಥೀಟಾ ಇದೆ ಅಂದಮೇಲೆ, ಹೀಗೆ ಇದಿಷ್ಟು ರೈಸ್ ಮಾಡಿ ಥೀಟಾ ಇದೆ ಅಂದಮೇಲೆ ಇಲ್ಲೇನಾಗುತ್ತೆ, ಇಷ್ಟು ಆ್ಯಂಗಲ್ನಾಗ ರೈಸ್ ಇರುತ್ತೆ. ಅವಾಗ ಏನಾಯ್ತು, ಇದ್ರ ಕಾಂಪೊನೆಂಟ್ ಅಂದರೆ ಏನು ಕಾಸ್ಟ್ ಇದು ಬೇಕಂದ್ರೆ W is equal to M into Z. And another one is force of friction. Force of friction ಇದರ ನಡುವೆ ಥೀಟಾ, ಇದು ಆಂಗಲ್ ಥೀಟಾ. Now this is resolved into two component. The Fs side theta side component Fs cos theta. Normal reaction resolved into two components. Theta side n cos theta. Perpendicular n side. Then force of friction theta side Fs cos theta. Perpendicular direction ಒಂದು ಹಿಂಗೆ ಕಾಂಪೊನೆಂಟ್, ಅದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇದೆ Fs side. W is equal to M into Z. What is theta here? Angle of banking. Now see here, what are the forces are acting? One is weight, another one is centripetal force, and one normal reaction. Another one is force of friction, another one is centripetal force. That is centripetal force is one more force is LCT MV square by R. One more force. Four forces. How many forces? Four forces. One is weight. W is equal to M into Z. Vertically downwards. Normal It is perpendicular to the surfaces where they are mounted one and another. And force of friction parallel to the surface which are contact one and another. And another one is centripetal force. This is m square r. M is mass. V is the velocity of the moving car. What about r? R is the radius of the circular car. Now see, this is normal reaction. It is resolved into two components. One of the component is theta side n cos theta. Another component is n side. This is force of friction. This is also resolved into two components. One is in this side Fs cos theta. Perpendicular to this one is Fs sin theta. Okay? Now this is n is resolved into two components, n cos theta and n sin theta. Fs is resolved into two components, Fs cos theta and Fs sin theta. Yes? Now the net force on car along vertical, along horizontal, that you have to take. Along vertical and along horizontal, that you have to take. The net force on car along vertical, this is ns cos theta. It is balanced by these two forces, Fs sin theta and mc. Therefore, n cos theta, this is equal to mc plus Fs sin theta. This is equation 1. You know this centripetal force. That centripetal force Fcp is equal to m square r. Then n sin theta plus Fs cos theta. This is along horizontal. This is along horizontal. This is for horizontal. Net force along horizontal. This is along vertical. N sin theta plus Fs cos theta. N sin theta. Innother Fs cos theta. It balanced by the centrifugal reaction force. That equal to centripetal. Centrifugal reaction is equal to centripetal. And now this is equal to this one. m square. ಇದೇನು ಮಾಡ್ತದ ಪೂರ್ತಿ ಈ ಕಡೆ ಬರೋಲ್ಲ, ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡೋ ಫೋರ್ಸ್ ನೋ ಬರುತ್ತೆ, ಯಾವುದು ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ರಿಯಾಕ್ಷನ್, ಬಟ್ ದಟ್ ಈಕ್ವಲ್ ಟು ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ದಿಸ್ ಇಸ್ ದಿಸ್ way. Then Fs is equal to mu s into n. You know this force of friction is coefficient of friction and what is the normal reaction. Yes. Now equation 1 becomes equation 1 n cos theta plus mg plus lg instead of Fs mu s into n. Yes, now going to take this term is on this side, n cos theta minus mu s n sin theta. Then you take the common n is equal to cos n into bracket cos theta minus mu s sin theta. Now you take the n is equal to mc upon cos theta minus mu s sin theta. Now equation 2 becomes from this situation. Again you take here Fs is mu s into n here, n sin theta plus mu s n cos theta is equal to, it becomes m max square divided by ಯಾಕೆ ನಾವು ತಗೊಂಡಲ್ಲ Fs mu s into now v becomes v max. Now we take the n common here, n into bracket sin theta plus mu s cos m of v max square divided by. Substitute n ಇದನ್ನ substitute ಮಾಡಿ ಇದು mg upon cos theta minus mu s sin theta. This is n into bracket as it is sin theta plus mu s cos theta. m v max square divided by. Here m get cancels. What about v max square? V max square is equal to, this is r into g into sin theta plus mu s cos theta divided by as it is cos theta minus mu s sin theta. Now you take the common here. Now to do here. Now to take the common here. What is the common here? What you have to take the common? Cos theta of the common. On numerator and denominator. Yes. P max square is equal to Rg cos theta into bracket cos theta over take common. This is sin theta upon cos theta. Yes, plus cos theta over take common here. Yes, fine. Okay. Divided by here you take the cos theta common. Cos theta into bracket 1 minus mu s sin theta divided by cos theta. Why do you take the common here cos theta? Because it is in the form of sin theta by cos theta here. It is in the form of sin theta by cos theta. Again you multiply, you got the same expression. Cos theta is equal to P max square is equal to what I would take here? Rg. This is the tan theta plus mu s. Fine. Okay. Divided by that is 1 minus mu s tan theta. This is the expression. Therefore, P max is equal to what do we take here? That is equal to yes. P max is equal to under root of Rg into bracket tan theta plus mu s divided by 1 minus mu s tan theta. This is the expression for the maximum speed of the vehicle on banked road without skidding. On the banked road, speed maximum ಎಷ್ಟಿರಬೇಕು. Now this depending upon this maximum speed depending upon here in this case us and r. Here also depending upon the here in this case Pmax depends on radius us and theta. Theta into ಕೊಡ್ತಾರೆ. If theta ಇಂತಿಲ್ಲ ಇಲ್ಲಿ if us is equal to 0 there is no friction. At that time Pmax is equal to it becomes 0 under root of Rg tan theta. This is 0, it becomes 0 and it is divided by 1. It is divided by 1. Therefore Pmax is equal to under root of Rg tan theta. This is the expression for the maximum speed of the car move on a banked road. It is in the absence of friction. This is now this is in the presence of friction. It is in the presence of friction. Now this becomes here Pmax square is equal to Rg tan theta. Tan theta is equal to Vmax square divided by Rg. Then theta is equal to tan inverse of this is Pmax square divided by Rg. This is the expression. Now this is about the maximum speed of the moving car on the level road. What is becomes theta here? Theta is equal to that is tan inverse of. When you use this expression, ಇದನ್ನು ಯಾವಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಇದನ್ನು ಯಾವಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ? This is the expression for the angle of banking. This is without friction. Friction ಇಲ್ಲದೆ ಇದ್ದಾಗ ಯೂಸ್ ಮಾಡಬೇಕಷ್ಟೇ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾವೊಂದು ಬೈಕ್ ತೊಗೊಂಡು ಹೋಗ್ತೀನಿ ಅಥವಾ ಬೈಸೈಕಲ್ ತೊಗೊಂಡು ಹೋಗ್ತೀನಿ, ಆಮೇಲೆ ಹೀಗೆ ಹೋಗುವಾಗ ಸ್ವಲ್ಪ ಟರ್ನ್ ತೊಗೋತೀನಿ ಅಂದರೆ ಟರ್ನ್ ತೊಗೊಂಡಾಗ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಹಿಂಗೆ ಇರ್ತೈತಿ. ನೀವು ಹೀಗೆ ನಿಂತಿರಂಗಿಲ್ಲ, ನಿಮ್ಮ ವೆಹಿಕಲ್ ಸ್ವಲ್ಪ ಬಾಗ್ತದೆ. ಎಷ್ಟು ಬಾಗ್ತದಲ್ಲ ದ್ಯಾಟ್ ಆ್ಯಂಗಲ್ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದಿಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್. ಓಕೆ, ಇನ್ ದಿಸ್ discussion, in this video clip I want to discuss about that is the moving car on the leveled road. Moving car on the leveled road and moving car on the banked road. What is the expression for the maximum speed of the moving car on the leveled road? This is the expression. Ms into RC. Ms is force of friction. That is coefficient of friction. R is radius of the circular path. G is the acceleration to the body. On banked road, that expression Vmax is equal to under root of Rg to bracket tan theta plus Vs divided by 1 minus Vs tan theta. If in the absence of friction, Vmax is equal to under root of Rg tan theta. Okay, at that time tan theta is equal to Vmax square divided by Rg. Now theta is equal to tan inverse of Vmax square divided by Rg. That is equal to calculate. Okay, this is about. It's a one very important typical diagram is there here, because you have to resolve the forces in two components here. Now ಎರಡು component ಆಗಿ force of friction ಎರಡು component ಆಗಿ resolve ಮಾಡ್ತೀವಿ. ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ನಾವು ಅಲ್ಲಿ ನಾವು ಎರಡು ಪಾರ್ಟ್ ಆಗಿ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ರಿಸಾಲ್ವ್ ಮಾಡೋದ್ರಾಗ ಸ್ವಲ್ಪ ನಿಮಗೆ ಡಿಫಿಕಲ್ಟ್ ಅನಿಸ್ತದೆ, ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಅನಿಸ್ತದೆ. ಬಟ್ ಪದೇ ಪದೇ ಈ ವಿಡಿಯೋ ಕ್ಲಿಪ್ ನೋಡ್ರಿ ಒಂದು ಐಡಿಯಾ ಬರ್ತದೆ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. Before going to close this video clip, stop this video clip, I want to request all of you become a subscriber for our channel. You press the subscriber button and bell button, and then you become a subscriber for our channel. Okay, thank you for one and all. Okay, I hope all of you become a subscriber for our channel. Yes, thank you. ಮತ್ತೆ ಮತ್ತೆ ವಿಡಿಯೋ ಕ್ಲಿಪ್ ನೋಡಿರಿ, ಅಂದರೆ ನಿಮ್ಗೆ ಏನು ಬರುತ್ತೆ, ಒಂದು ಐಡಿಯಾ ಬರುತ್ತೆ. ರಿಸಲ್ಯೂಷನ್ ಮಾಡಿರೋದು, ರಿಸಾಲ್ವ್ ಮಾಡಿರೋದು,